All right, we're going to go ahead and get going here. So thanks for coming. My name is Adrian Samays, and I manage our Microsoft specialist community within EMC. And with me I have Chaman Berturan, who is a senior manager within our partner engineering team up in Redmond, helping to do a lot of integration with our software in Microsoft. And what we want to do is talk to you today about Microsoft Private Cloud amplified with EMC. What does that mean, right? So what we're going to do is kind of walk through some of the tools that are available from EMC, tools that are available from Microsoft, largely around their System Center 2012 suite, and talk about how do we use these tools to be able to help with things like improved automation and efficiencies in your environment. And so if you'll stick with me, I have a few slides up front, and then we're going to jump into a series of demos to kind of show how this stuff works together. So, I'll call it the typical cloud story, right? We hear a lot about the cloud. Everybody talks about the cloud. What is the cloud? So for us, the cloud is really a series of different technologies. It's, private cloud, which I think a lot of customers are well ahead of starting to implement. So looking at using things like virtualization to be able to implement an internal private cloud. And what we see is there's a series of steps in implementing a private cloud. So it's really starting off with doing some virtualization through IT production services, finding some low-hanging fruit, expanding that out into more business-critical applications, and then really achieving IT as a service. But we're also seeing a lot of customers who are interested in public clouds, right? Looking at how can they actually take services and move it off to the public cloud, completely moving it off-site and having it be managed by somebody else. And then in between is the hybrid cloud, right? So you have some services that are kept on-site, some that are being managed off-site, and some really management of these services and trying to find a way, a balance essentially on how to manage these services between the two. But in the end, really, what does cloud mean, right? We all talk about cloud. Walk through the exhibitor hall, there's clouds everywhere and people selling clouds, and but really I will say there's no one definition. Cloud is really what it means to you. So for what it means to me, it really means finding increased efficiencies, right? And so what I mean by that is being able to drive savings across the organization. That's what we find that why people are so interested in cloud today. It's not necessarily what the cloud technologies are, but it's finding ways to improve efficiencies in their environment. So being able to save money across the organization, be able to save on hardware costs, on software costs, but also be able to increase automation, right? So reduce operational costs. There's a high amount of costs associated with managing these environments, obviously, and going through and managing a data center. And the other really compelling reason is increased agility, right? So giving customers, giving end users the ability to, have more IT resources for innovation and value add activities. So instead of spending all your time managing, servers and SANs and software, being able to have increased agility, right? To be able to now spend your time doing things that are more useful to the organization, finding ways to increase productivity through greater IT responsiveness. So in other words, being available to be able to respond, so being more proactive instead of reactionary. And really letting IT be a partner of the organization. So again, instead of just being the ones who, service help desk calls and allocate storage out to a particular department, actually be part of the strategic direction of the company, helping to decide what technologies can help take the company into the next, moving forward into their next, being able to achieve the company goals and into the next direction. But really, I think the key here is that we're looking to not just virtualize, but automate, right? So a lot of people are looking at virtualization and saying, we've now implemented a private cloud. Virtualization is a great step, but it really is not, virtualization alone is not the answer. There's so much more to actually do end-to-end automation to allow, to actually be able to see the benefits of virtualization, and that's some of the stuff we're going to look at today. So virtualization is just the beginning. There's so much more to it. So automation, Being able to do operational efficiencies, being able to do simplified management, orchestration of the environment, being able to actually give provisioning out to the end users, allowing them to request services and have it automatically happen. Being able to have services end-to-end, be able to have new VMs created, new data created, automatically deployed, automatic failover. And really, so virtualization is the foundation for this. And a key thing to be able to make this happen is that, traditionally IT is too slow. It's been too rigid. So taking traditional IT processes and trying to make this happen really probably won't work. This is going to require going through and developing new business models to be able to achieve it. It's like trying to take traditional best practices and implement them in a virtualization environment. It doesn't really apply anymore. So to be able to truly do this, it requires business IT or business models to change, right? To be able to actually now have the organizations talking to one another, these processes connected, and being able to seamlessly move data across sites. It's going to require a new way of thinking. So really what we're doing is we're thinking about looking ahead. What if we could do these things? What if we could, we could let end users request storage volumes and virtual machines, right? Being able to have those requests automatically configured and deployed automatically sets up help desk tickets to send out alerts and notifications to people. Being able to track the usage of these resources and be able to enable chargeback. A lot of people think about chargeback as a service provider, but it doesn't have to be. It can give, actually, for departments, it can give you the ability to charge back to various departments to be able to help now fund IT resources and to be able to help understand which departments are over-allocating or overusing the resources. Being able to follow issues in the data center, automatically send alerts and open trouble tickets, maybe even collect data within the environment, package that up and send it off as part of the alert process. And allowing VMs to not only just fail over from site to site, but maybe in some cases they never go down, right? So VMs just move from place to place, but always stay online. Those are some of the end goals that we're looking at and that we want to talk about and showcase today. The key here is that, we're the guys up on the boat in the corner working on our laptop. This doesn't mean by automating processes that, the IT operator role goes away. It means that you move from being less reactionary to responding to problems to actually being, more strategic, more involved in the business processes and being able to help design this to help make the company more successful. So some of the key components that helps make this happen. So the way we're looking at it is from the top down, right? From the server, a lot of new tools from Microsoft that we've talked about this week. So System Center 2012, such as the Virtual Machine Manager, Operations Manager, and Orchestrator are some of the technologies that we're going to look at today and that we're integrating that's going to help do this work to be able to help automate it. And I say from the bottom up, so from the storage up, we have our own set of tool sets, things like EMC Storage Integrator, or ESI, which allows us to do simple provisioning for a Windows environment, whether it's a physical or virtual. And then in the middle, we have PowerShell, right? So common set of commandlets that allows us to be able to do full scripting, full automation of storage, network, servers, the entire environment. So ESI. ESI is a tool from EMC that we provide for free to our customers. And what ESI does is allows the end users to essentially be able to simply provision storage for a Windows environment. So what we mean by that is we have a set of wizards that are presented to the end user that allows you to do things like create a new drive on a storage array, present it out to Windows, present it as a clustered drive, being able to actually automatically deploy new applications on that drive. Because what we found is a lot of our customers complain that it took a long time to be able to just allocate storage and create a drive for a Windows environment. The reason why is typically this goes through different departments and different set of users, right? So somebody requests, hey, I need a new storage volume and a new LUN for this new application. And that has to go through an IT process, help desk request. It goes to the storage admin, right, to go in and to allocate the storage and to set the zoning, give the permissions to the server. be able to go create the LUN, turn it over to the server administrator, create that new LUN, format it, assign a drive letter, do all the disk offset, present that into Windows. Now it could get presented over to a cluster administrator for high availability. Could get presented to a administrator who needs to create Hyper-V on this new server, a new LUN. And it's a series of tasks that can take a long time, and what we found is a process that could take a long time. It was frustrating. So ESI essentially goes through and simplifies this. So whether it's for the end user to request a server administrator, storage administrator, it presents a series of wizards that allows you to create new drives, answer some common questions around how big, what drive letter, and it automatically will do all these tasks in the background. It'll present this into a Hyper-V or pure Windows environment, have the drive available, and again, make it a cluster drive if you choose to. You can even say, I want to deploy a new SharePoint farm on this new drive, and it'll automatically ask some questions and automatically deploy SharePoint on this new drive. So it has a really end-to-end creation for storage tasks in a Windows environment. The great thing is it's based on MMS. It's an agentless tool. It supports both our block operations as well as file. And everything that we can do in the GUI has a set of commandlets behind it. So you can actually script all these tools as well. And we're going to walk through that a little bit. Does this work for vPlex? I think is the question. Not yet. But it does support many of our storage arrays. So our older Clarion arrays, our newer VNX, VMAX, and et cetera. So we have a long list of arrays it does support. So let's go ahead and look at a use case scenario. We have a company who wants to deploy a new CSV volume. What we're going to do is use ESI to go through and actually, as a tool, to be able to understand what current storage resources are available. And then we're going to go ahead and do PowerShell to create the new storage details, to be able to create the new CSV LUN, present it to the cluster, and even be able to do some configuration on a Cisco UCS and implement boot from SAN.
And this is where I step in. So I'm your demo person for today. And I'll let the accent sink in a little bit before we get going. So Adrian's right. A lot of people have given us a lot of feedback about these environments are getting much more complicated, and it's very hard to visualize the environment and understand where all of these relationships are. So we are attempting to solve two problems. One is the automation aspect, and the other one is the visualization aspect as well, to help people understand where those storage entities are. So you're going to see a couple of things in the demonstration. These aren't live, so you're not going to see me typing, but they were live recordings from the system. So we do have access to the services and the servers in the system. So if anyone wants to dig into anything, we can do that. So ESI, our storage integrator. As Adrian said, it's an MMC, not MMS.
Oh,
and it gives you a visualization of an environment. And that environment comprises of a storage infrastructure, some number of servers, and a bunch of storage that's presented. So we have the ability to detail those in the environment. Clearly, we have a storage array. And so in this case, we have a VNX array. In the VNX, we have these entities called pools. And storage pools are where we create those objects that we present to hosts called LUNs. And so we have the ability to visualize the relationship of pools and LUNs, and then also the hosts. So we want to be able to tell you what the hosts are that are using LUNs from the system. For those, host names are irrelevant to us. Worldwide names, initiator addresses are important. Storage groups are the aggregation of LUNs to hosts in our environment. So we visualize the host as well. Again, we get that information through WMI as we call out to the system. So for any host, we can then look at the storage devices that are presented to it, those LUNs, where they come from, so the names that we've associated to the LUN, the pool that the LUN came from, and for the server, its initiator. So in this instance, it's an iSCSI connection. We also support aggregation because in a lot of cases, customers are doing things like putting in clusters. So we get some information about the cluster, and obviously we can look at the nodes that comprise it. And then for all of the nodes that are in that aggregation, we obviously have to know about the initiators, because those are the things that we're going to be presenting storage devices to. So we present all of that information in this kind of unified manner. So what we also do is ship PowerShell commandlets, and we do that through our PowerShell toolkit. So we're going to step through, this is a standard toolkit, a PowerShell commandlet library. When we load that system up, we can look at all of the commands that are represented within the library itself. So there's a range of EMC-specific functionality that we provide. And you can do things like there's a get EMC storage system. So in the same way that we could look at the storage array in the UI, we can get EMC storage system. And now I get an object that represents the storage array. So we have a number of properties that can be passed. This fully supports pipelining. So these are true objects that you can interact with and do certain things. Same way we can see the storage pools, we can do it through our PowerShell library, get EMC storage pool. This is an array of objects. Obviously, that's a lot of content. You probably don't want it, but because these are now standard objects, we can look at specific properties. So give me the property name and the available capacity. So now we can look at those objects, and we can also correlate that back to what we were seeing in ESI. So it's the same user experience, just represented in different ways. So from a reporting point of view, we can look at all of the storage pools that exist in the system, and then we get a representation of that in our PowerShell library and these objects that we create. So for any pool, then, we can see the same level of details. We didn't look at the RAID type of the device, but those properties are also represented through the objects. In the same way, we can get LUNs. So now we can look at the array, we can see the storage pools that are created and the LUNs that are assigned to us. So here are all of the LUNs that we also saw in ESI. There's one that we created. We'll be using this later. So compute CSV, it's a terabyte in size. So we can specify that. Again, pipelining is fully supported in this because these are just PowerShell objects that we're passing around. So that kind of completes all of our storage infrastructure. But we need to be able to manage those hosts as well. So we have a get EMC host system, and this reaches out into that environment and gets information about the hosts. So we look at physical hosts, but we also have virtual machines. So we understand virtual machines, and we can look at things like iSCSI initiators in them. So when we represent storage to them. Equally, cluster objects. So this is an entity that represents all of the physical machines that are in a cluster. So let's not just report, let's do. So get my array, get me a storage pool, the large pool, create me a new LUN. So we're going to create this compute CSV new LUN. So we can do that through PowerShell, execute the creation of it, and now get a cluster and present that device to the cluster. Now the cluster represents a number of nodes, so you'll see some activity in the background. As things change, we will see them reflected in the user interface as well. So we created that compute CSV new item. It's a 2 terabyte LUN. So that gets surfaced up into the user interface when we refresh it as well. So there's a correlation and persistence between the two systems. So we're out there, we're talking to all of the nodes, and we're presenting this LUN to them. Of course, this is just like any other operation where the LUN gets presented and it's left in an offline state. So if we need to do something with that LUN rather than just present it, we would connect to the array, the cluster, get the LUN, and get the host representation. And now we can do some intelligent things with that LUN that's now being presented. Well, first of all, we have to put it in an online state, because typically the SAN policy says it's in an offline state. We also have commandlets that allow us to change the read-only state to read-write, which kind of happens when you bring a disk online in Disk Administrator, and then initialize it. We can now create a volume on the LUN. So we create a new LUN, we go out and we format it, we allow you to support for we'll go to the CSVs, but NTFS, MBR, and GPT devices. So once we've done that, we can refresh the view, because a new disk signature has been assigned to that device, and now we can add it to the cluster. And in this case, we've actually added one attribute, and we're saying, bring it online as a cluster shared volume. So through PowerShell, we've now gone through the process of creating that device, presenting it to a cluster configuration, importing it into the cluster, and turning that thing into a CSV. So if we go to the node, well, one of the nodes that's in the cluster, what we end up seeing is now the end result of that activity. And we see this cluster shared volume that's been presented into the system. So here's the device that we formatted and presented, and disk 4 happens to be the other LUN that was presented, the 2 terabyte device. So now we have the opportunity to visualize the environment, understand what's going on, and also automate. And that's the first leg of effectively a trifecta of things that we are doing in these environments. So creating net new storage and presenting it, yeah, it's kind of interesting, right? But there's an opportunity now for us to do even smarter things. And one of the things that we can do is when we work with some of our server partners. And Cisco is a partner that we do great things with. Just as out of interest, people that use Cisco UCS Blade systems, the B series. Got a few? All right. So in those environments, and the nice thing about the UCS Blade system is they have this concept of a service profile. And a service profile is a representation of the physical attributes of a server. Things like the initiator information. That can be pushed out to a physical Blade server. And so if I can abstract things like the worldwide initiator name, and I can create a LUN and present it to a host, maybe I can do things like SAN boot that thing, right? And if I can do that, and I have a sysprep image on a storage device, and I can replicate that, now I get the opportunity to do something much more intelligent. So those of you that saw the keynote, the first keynote, you would have seen Vijay Tiwari running around for several hours while servers were being deployed. What we're about to do is a 4-minute run of presenting a system, a bare metal install, and booting it up. So here's a view of UCS Manager. And we have a number of physical machines or service profiles. There's one that's powered down. It's Hyper-V 03. Again, this has a representation of some attributes. It doesn't have any local disks. It does have initiators. So if we connect to this system, it's down at the moment, and we can do some intelligent stuff. I do have a LUN out there with a sysprepped image. So let's go to our storage view. This is Unisphere. It kind of gives you a representation of what's physically in the system. We have this thing called Compute Node Master. It is a sysprepped image. There are 2 copies, the snapshots on it at the moment. So similar to our PowerShell library, Cisco have a PowerShell commandlet library. We'll load those up. We'll get that node, that service profile. We're going to connect to UCS Manager, and we're also going to connect to the array. And now we're going to do some stuff, like get the service profile. And the service profile gets us some interesting information. Cisco, through their PowerShell library, return us objects that represent the virtual HBAs. So now I can get information about the initiators that that service profile might use to boot from. These include the node name and then the port address. So we can now do something with that information. Well, first, go out and get that master LUN. And once I've got that object, create me a snapshot of it and return the snapshot object, and we're returning it as my LUN. So we create a session and then get a LUN. And the LUN's created. Now what I want to do is turn around and present that LUN. We'll look at so we'll see this as the third snap that's been created from that master image. Now I can turn around with that object and generate a registration for that system. And so now I'm physically presenting that LUN to the initiators, and because the BIOS settings allow us to define that it's a boot from SAN environment, once those initiators are created, I can now turn around to the service profile through UCS Manager in PowerShell and power it up. What we end up seeing is that service profile booting up. The first thing, it does a BIOS reset. We end up seeing the initiators that the system is going to, or the targets that the initiators can see, and these are the representation of our array. Once it's detected that, BIOS will now boot. What we end up with is a system coming online from a sysprepped image. So in 4 minutes, we've been able to get to the array, identify a master LUN, create a snapshot of it, present it to a host, power up. So bare metal provisioning without really having to do anything other than write a few PowerShell scripts. And so this begins that process of offering up these dynamic environments that people can quickly provision and give you the opportunity to be sitting out on that boat. So at this point, I think I'm done for this part of the demo.
All right.
Back to Adrian.
So this is great, and it's a great series of tools, but we also know not everybody's using PowerShell. Not everybody is going to, add in another, tool like ESI. But, in some environments, customers are using System Center, and they're looking to ways to be able to continue to manage their storage arrays and storage operations through System Center. And so that's great. We offer that too, so that we can give customers the option for whatever they want to do. And new in SCVMM 2012 is the ability to, manage storage and to start doing some storage tasks, right? So through SCVMM 2012, you can do things like discover storage arrays, being able to create LUNs, being able to do creating storage pools, and be able to set classifications for your storage to be able to better manage it and better understand what's available. And from here, you can start doing rapid provisioning of VMs, right? And being able to have that relationship of storage into the VM libraries and what's going on. And this is all made possible through SMIS, right? So SMIS is technology. It's developed by SNIA and maintained by SNIA. It's an organization EMC participates in, as well as other companies out there. And essentially what it does is it allows us to be able to do a standards approach to managing storage. So that by having a SMIS target, such as an EMC array, you can easily be able to plug in and be able to see that and use it in SCVMM 2012. So what we want to do is go ahead and show you a demo. So let's do a similar type thing of what we just went through, but let's go through and use SCVMM 2012 to be able to connect to the EMC array and the EMC LUN through SMIS, and then go ahead and deploy a new VM from a template, and then being able to use EMC snapshots within SCVMM 2012 to then rapidly deploy that VM.
So, some of you are obviously PowerShell people, but we wanted to also provide the ability to abstract that out, right? Not everyone wants to write their own PowerShell. So this becomes a second leg of our infrastructure. And of course, System Center 2012 now has a storage management service. We're going to see that evolve. It's been announced that in Windows Server 2012, you're also going to see an extension of the storage management service, and one of the components that supports it is this SMIS interface. So let's go to Virtual Machine Manager 2012. And in this environment, we have a number of clouds that we've created in the environment. And if we go to the Fabric, in the Fabric Management tab, we have this area at the bottom that represents storage objects. And we have providers. This is our SMIS component. It lives out somewhere on one of the servers in the infrastructure, and it allows us to represent an array and properties. So some of the things that we can control are how it's going to do replication, the storage pools. These are the same pools that we saw through PowerShell and ESI, and we bring those into the system. And when we see them, we also then get a similar view that we were seeing of these pools, the LUNs that are represented within them. So here's our compute CSV LUN that was created, and attributes about them. So where are they presented? So these are presented out to the system. So VMM can now do discovery. Well, it can do discovery even on the library server. So if you have a VHD out there on the library server that's sitting on a LUN, the system can detect that. And it can say, this device is SAN copy capable. That means I can make a copy of it and present it out into the environment. And we do that through templates. And a template is a representation not only of the VHD that is sysprepped, but also what does a physical machine look like. So here's the location of the VHD. On the library server, that's actually a mount point on the array. What we're going to do is change one of the attributes. We're going to make this a highly available VM, and it's a Windows 7 Enterprise Edition system. So we've got this template now. It's SAN copy capable. We can go to our cloud, and we can say, you know what? Well, first of all, let's have a look. There's nothing in the cloud at the moment, right? So we have these 4 nodes. This is the same cluster that we were seeing before. And in the cluster environment, it's pristine. It's newly installed. It doesn't have any services out there. It doesn't have any virtual machines. What we're going to do through System Center Virtual Machine Manager is now push out a virtual machine into that environment. So we select the virtual machine that we want to deploy. This is our template. Here's our Windows 7 environment. It pulls in information about that environment, wants us to give it a name. This is the representation within Virtual Machine Manager itself. So this will be externalized later. You'll see it floating around in the environment as we go through the demo. And then we look at the hardware configuration. And of course, we see the VHD, we see the property that we changed. This is highly available. And then we continue on that process of provisioning it. So we'll see this one later, but we're going to push this out into a cloud. And in our environment, there are effectively 2 clouds. We have a compute and a management cloud. But we're going to push it out to the compute cloud. And what we see is the transfer type of SAN. And it's SAN because these systems are connected to the same array that SMIS is managing. So we give the computer name. Now, this is the name of the virtual machine, the operating system name. We'll default Pro. You can look at all of the PowerShell. So you can then build your own PowerShell if you want to through the standards-based approach. When we deploy that out, a job is created to create the virtual machine. And one of the things that it's going to do is it will go out and talk via SMIS to the array. And it'll say, you know that LUN that you've got that's got the VHD, create a copy of it. And that is represented by this rapid deploy using SAN copy. So at some point, an operation gets executed that, in this case, because we set it up as a snapshot, will create a snapshot against that source device, all managed through SMIS. So here's our view into the array itself. And my named LUN is Windows 7 Server Enterprise, and there's my snapshot. So the snapshot got created. Now that snapshot is being pushed out into the cluster, presented to all of the cluster nodes. And what we'll see through Cluster Manager on the system, the storage becomes available as a cluster disk, and a new service gets created. And there's a preface of SCVMM for anything that VMM created. So there's the disk. That is the snapshot. It's got a VHD on it. We created a virtual machine as a service within the cluster, and VMM will bring that online. So here's a way to abstract away needing to do it through PowerShell, doing it in a standards way, using templates within Virtual Machine Manager. So this becomes the second part of our three-part way of managing these infrastructures. And so that system will boot up. The nice thing about driving it through Virtual Machine Manager is Virtual Machine Manager will then connect the answer file and go through all of the generalization of the virtual machine infrastructure itself. So standards-based deployment making life easier for the administrator. So now you can write your own PowerShell, you can use VMM 2012 and an SMIS provider to go out and do rapid deployment in the environment. Much faster than doing the network-based copies. Back to Adrian.
So again, this is great. Now we've got VM deployment, storage management happening through PowerShell, through ESI, through System Center, Virtual Machine Manager. But we're looking at and going, okay, so this is great, but now how do I, better manage my storage and have an understanding of how it fits in the organization? So leveraging technologies like SCOM, so being able to understand the health and relationship of storage in a SCOM environment, right? So one of the things with SCOM is, it gives you a great view of your servers, your clients, your applications, your networking devices. How do I extend that out to the storage? So being able to use things like management packs to be able to pull in the storage arrays into a SCOM view, and being able to understand the relationship of all your storage objects, how they fit in the environment, and overall how they fit with the VMs, the applications, and the servers. So being able to do monitoring, alert, diagnostics, being able to understand if you have drive failures and be able to drill in and find out, what's that impacting, understand, what could be the cause of it and how to actually issue off automatic alerts as part of that. And so what we have here is, for instance, screenshot of what we have available, for instance, for our VNX array. So we have a VNX array within SCOM now where we can start drilling in and we can look at the different storage processors, all the different devices that have been created, LUNs, drives, the health of all this, the relationship of all these devices. And even to the point as if we have a drive fail in this environment where it would issue out essentially, it would red X and send out a set of alerts in the environment, that what it'll do is it'll show the relationship and actually go through and show what, for instance, servers are connected to that drive, what VMs are using that drive, what applications are using that drive, and be able to set alerts through all those. So now I could know I have a drive that's failed in my array, and it's actually taken down my SharePoint server that's running on a VM because it shares part of that drive. And I can have that whole end-to-end kind of monitor and alert occur as part of it.
A drive failure wouldn't bring down the system.
No, it's not, and not in a enterprise class array, but as an example, and you're right, but as an example, as a series of drives, which wouldn't happen either, of course. So, but what does this give us the ability to do, right? So by doing this, it allows us to be able to actually create workloads and make them highly available. So it's not just about monitoring and understanding that when we have a series of drives fail, what the impact could be, but it also gives us the ability to do things like leverage Microsoft Pro Packs, right? So Pro Packs to be able to now set, let's give the administrator an actionable event to say, okay, there's been a failure in the environment, what would you like to do about this? Or before a failure even occurs, there's a warning coming up saying, for instance, there's a high utilization on this server. There's a potential low disk space in this volume that somebody's been filling up. Would you like to move these highly available VMs to another volume that has more available space before that volume does fill up and eventually causes data loss? And even to the point of, say, for instance, being able to kick off a Pro Pack to say, let's move these VMs off of a particular set of servers and arrays and move it to another set of servers or arrays to keep them highly available. Again, helping to address problems before they get in the environment, so to help keep these workloads up and available. And leveraging things like even storage virtualization, right? So we have the ability to take LUNs and essentially detach them from the physical server themselves, put them in a virtual layer, so that you don't have to manage VMs LUNs and have them replicated between physical sites, and being able to have VMs then easily move from one place to another, right? So with live migration, it's going to keep that VM and the services running at all times, and being able to always find a destination as it moves around, so to keep your workloads available. But a lot of what we're talking about is how to manage the environment from the administrator standpoint. Well, what about extending this out to the end users, right? So at some point, we want to give the end users the ability to request services and to have those services happen automatically. So again, what if having a request for that drive that we had to then go through and create with ESI and run a lot of PowerShell commands to be able to deploy a new VM. Well, if I have an administrator, or an end user who has interest in wants a VM, what about giving them the ability to essentially use the portal to go through, request the VM, and have that operation occur automatically to present it to them? So we're using things like System Center Orchestrator to help with that workflow. So Orchestrator allows you to create these runbooks that allows you to automate some tasks in the environment to help have through a workflow of processes. So do things like create the file system, create LUNs, delete LUNs, disassociate LUNs from hosts. These are some of the tasks that we've been playing with and creating, as well as it really presents a lot of scenarios. So it allows for end customers to develop their own runbooks, as well as for us to develop and to be able to present to customers. So we're going to look at how to automate storage provisioning through a series of tools.
All right. So Orchestrator is one of those enabling tools, and we talked a little bit about Pro, and so there's all sorts of things that you can do, and Pro packs can come from any range of entities. HBA vendors are doing it. We've got server partners that are also generating them. So we don't know what all of the activities are that customers, or runbooks that customers will want to do. But we do want to show you the opportunities. So we talked about, just to reiterate, we've done PowerShell, we've done SMIS, and now we've got an opportunity for you guys to abstract it away and use tools within System Center to create your own unique operations. So in the world of Orchestrator, we have an integration pack that allows you to go out and build activities. And so here we've got a very simple runbook that we're creating. And really, it's just going out and creating a LUN on the array, it's presenting it to a host, and it's formatting that device and bringing it online, right? It's a pretty straightforward sort of runbook just to demonstrate that those activities can be chained together. And it uses the data bus to push a lot of this data through. So this information is being manually entered in the runbook tester, but it would be automated through some sort of service manager request or a web user interface. But we provide enough information to identify what we want to do and where we want that device to appear. The runbook then executes, and we have some of those activities. Create a new LUN, present the LUN to the host, format the LUN, right? Create a file system on it. And once it's been executed, the end result is that on the server that we're targeting, which is actually this machine, if we go into something like Server Manager and then Storage Management, we see the end result of that, and that is that we've created this device that we've presented. Now, it's a very simple kind of scenario to implement, but you can generate all sorts of interesting things. So we would plan to fully support all of those demonstrations that we have with presenting to clusters and creating CSVs and moving devices around. So there's that whole set of activities that will be presented through our integration pack. So now you can write your own PowerShell, you can use VMM, or you can use Orchestrator. You're surrounding the storage. We're giving you all of the choices, right? And we talked about that self-service mentality. And there's one other thing that we want to talk about, and that is System Center App Controller. So App Controller is really interesting. So we've talked about LUNs and pushing out VHDs and doing stuff. Well, sometimes that makes sense, but invariably there is an application and there's a service that you want to do. And now we have the opportunity to tie it all together and kind of show you that whole self-service model and more kind of integrated configurations. So back to VMM. So in VMM, in the library, we can create these things called service templates. And service templates allow us to tie a number of templates together and add some more functionality. In this case, we have some resources that are used by this template that we've got called SQL and tier. Two VHDs. So we're going to push out 2 virtual machines in this environment. So the service template is created. Through App Controller, we now have a visualization of the environment, our clouds. We have those 2 clouds, EMC Compute and EMC Management. So in the compute environment, I might want to deploy a service. Now it's more than just a VM. So I select a template. I can, of course, select the templates that we want, but I'm going to do that SQL and app tier. It brings in a configuration of that service. It allows me to go out and manage some of the attributes of it. So I might give some of these services names. So here's my MMS application. I can go to each of those entities that's going to be pushed out. So I've got I think this one's the application tier, just giving it a name. So it is a Windows Server Enterprise Edition. It uses that other VHD that's in the environment. And here's my SQL tier. So now I can create this environment, the networking infrastructure, and I can just say deploy. Job submitted. Back in VMM, the wheels are turning. And here, what we end up seeing, if we go to our jobs view, is the operation that's deploying that service. So it knows that there's a couple of VHDs that need to be deployed. So we see things like deploy using SAN copy, because it knows that that VHD is on a LUN that it can replicate. And it's doing exactly the same sort of thing that we saw in that job where I submitted the virtual machine from the system. We can see the view, and in this environment, if I go to the VM tabs, I'll see a number of systems. We kind of deployed a number of these out into the environment and pushed them. Here are the 2 that are being presented. If we go to our virtual machine or our cluster node now, what we'll see is those other services. And now what you'll start to see is these new services appearing. The devices are being created, the LUNs are being pushed out, and we're bringing these services online within the cluster. So here's one of those virtual machines, and there's the other one. So we're rapidly deploying the VHD that represents these entities within our application, and now we've got a full scenario that's being deployed out into the environment. Again, these systems are going out and using Snapshot because that's what the SMIS provider is configured for. So in this server, this master environment, here are the 2 snaps that were created, and that was run on Wednesday when I recorded this. So in the environment then, we just see those services that are being deployed, and when it finally gets deployed out into the environment, it runs through the generalization of the configuration, then we can start using the system. So it's a self-service model to let people deploy complicated environments out into that cloud, right? So now you can do granular level management of devices if you want to. You can abstract it away and let VMM deal with it. Or you can use kind of a higher level architecture through orchestrator or through app center controller or application controller to go out and deploy these services into the environment. Which is great. There's only one problem. Man, that's a lot of work. So there are a lot of services that go into creating this infrastructure. So what we've done in these environments, and you would have seen the announce, is provide a mechanism to get all of that infrastructure out to you as a ready-to-run environment. So if you've heard about the Microsoft Private Cloud Fast Track configuration, these are systems that incorporate all of this technology, right? You don't have to go out and build your own. It's already built in. So you end up with a system that provides all of the resources that you require in that environment. And we're coming to market with two of those solutions. One that, in fact, what you've been seeing, all of these demonstrations, are on our private cloud infrastructure. So we have a solution that we're working with Cisco, and that kind of has some really nice attributes because of that service profile model, where we can do much more in terms of managing and orchestrating that environment. And then for people that might want another server vendor and some Brocade interaction, then we're also coming out with a configuration in that environment. So these systems bring all of the value proposition, the full System Center 2012 stack that includes virtual machine manager, service manager, app controller, all of the data warehouse capabilities, service manager, which is kind of one of the things that we didn't really talk about. So it's all pre-configured, pre-built in, and ready to run in these environments. So that stack kind of looks a little bit like this. What you end up seeing is the System Center stack. Today, it's Windows Server 2008 R2. In the future, that will obviously include things like Windows Server 2012 when we get to that environment. And in the configuration that we provide with Cisco, we start with 8 blades in a chassis, and we go up to a 16-node configuration, and you could technically go larger. For the storage environment, we are including an EMC VNX 5300, so it provides all of that infrastructure, right? So there's a requirement in these environments to create highly available services within VMs, and so you need iSCSI. Well, to do iSCSI, then you typically need VLANs. And when you have VLANs, you have to protect those, and you have to isolate them, and you have to do all of this great stuff. The benefit to you guys is that you don't have to build your own. It's all pre-configured in the system to provide all of that functionality to you. So we surround ourselves with the System Center family of products. And so it provides self-service portal capabilities, rapid deployment model, all of the eventing and alerting, all of the good stuff for reporting, and all of the services components. So it's a rapid deployment model for a relatively complex but very effective solution for deploying private cloud.
And even includes pre-configured PowerShell scripts, ESI, right? So all the tools that have been shown here.
Yep.
So, really in kind of closing here is we're talking about a lot of different technologies, but the point is that, when we talk about the cloud, right, don't just stop at virtualization. There's so much more that can be achieved, and there's all these tools that we're showing you that are available today that they make automation, really a simplified process to be able to now extend virtualization out to automate these services, right? To really be able to have some IT efficiencies, the agility that we talked about. Being able to have better utilization of your resources, your hardware, your servers, your storage, but also your people, right? Making sure that people are using their time wisely and how they're being, what they're being asked to do. And being able to provide more services to the end customer. With the Microsoft Private Fast Track that Chuman just talked about, makes all this easy as well. So a simple way to be able to, if you will, drop off a private cloud. have this already pre-configured, have all these tools ready, have all the services built in around it, and really being able to deliver predictable results is a key of that. So a lot of things we're talking about here are examples, right? We're talking about scenarios and walking you through Choman's lab of his private cloud fast track solution. You know, I recommend tomorrow there's a session called Real World Solutions from Traffic Verket. They're a great customer of ours, and they've adopted these technologies and they run it in production in their environment. So all the things that we've been talking about here, they're running to run their business. So they're going to go through and talk about what are they doing and how are they doing it, and what the benefits they've seen and why they've deployed a lot of these technologies. So tomorrow morning, in just down the hall here at 2201. And with that, we'll be available for questions. So, you know, please do complete your session evaluations. As Choman said, we have the environment actually running here that we can log into if there's more things you want to see, scenarios that you want to go through. And then as well as we're going to be at the EMC booth in the exhibit hall immediately after this session too, if you want to come by and spend some time with us. But with that, thank you for your time today. Any questions while we're here? Yeah.
Quick question on the UCS fast track. This was one switch. Do you provide two switches as staff for
Yes, so the question is around the view that we provided. Everything is redundant. So everything is connected in a highly available redundant way. So there are actually so there's two Nexus 50, 55, 48 or 58, whatever, the switch stuff. So everything, including all of the connectivity to the array itself and connections. So even the Nexus switches are cross-connected. So if any one service fails, there's full redundancy. What we didn't include is details about what we do at the net or the storage connectivity layer. So we even do MPIO. So everything is redundant. We use CHAP for iSCSI, protocol, security, you name it, it's included. It really is all of the best practices that you would hope to deploy done for you. So in a predictable, redundant manner. So, okay. Anyone else? You're all hanging around. I'm kind of impressed. So the question is about the fast track environments and why it includes VNX and what about some of the earlier generations. We are not building a fast track configuration. So two things come out of the fast track effort. One of them is a ready-to-run environment, which is great for customers. The second thing is a lot of the documentation to allow you to build your own, right? So we will talk about in the operations guide and in the deployment guide and in various white papers that we create around it, how to build that environment for yourself. We realize that we can't, because fast track is a very prescriptive environment, it includes a specific server and connectivity and storage array. Not everyone is going to fit that mold, right? But you will provide enough information for you to create, so SMIS supports CX4. There's nothing that we do in that environment that wouldn't operate in a CX4 environment. In fact, the VMM people at Microsoft use the CX4 for doing a lot of the automation through VMM itself. So you can definitely build your own, but in the prescriptive solution that is fast track, clearly we want to use the latest and greatest at the end of the day. So that's kind of it. It's a challenge to get everybody with every answer, but you'll be able to certainly leverage a lot of that functionality. So you're not limited in any way. There was a question. Oh, another?
So I heard about a capability called EX, Drop Loaded Transfer, 2012.
All right.
Snapshots used.
Yes. So the question is around some of the new technologies that are coming out in Windows Server 2012. And one of them that is being talked about quite a lot is this feature called the ODX, Offload Data Transfer. So what we're what we're demonstrating is the functionality as it's implemented today, because those solutions use Windows Server 2008 R2. In the Server 2012 timeframe, ODX becomes a reality, and you will start to see solutions that include that ODX functionality. So rather than taking a LUN and snapshotting the LUN, it gives us the opportunity to take a file system entity and create replicas of the file system entity, either in the same file system or on a different file system. So the future is bright in that respect. But it is a future, and I can't really say much more about it. But the technology is there, and things are only going to get much, much better. I think just before there's... Oh, okay. ODX questions. Yes? So, okay, so the question is around a roadmap for the Windows Server 2012. Clearly, we need to wait for... So a number of things have to happen. Clearly, Server 2012 needs to be available. And secondarily, we need the fast-track program to evolve into the next iteration. So today, it's V2. The previous version was V1, and it talked about the older set of System Center products. V2 is all about 2012 System Center. V3 promises to be about 2012 SP1 for System Center and Windows Server 2012. So that's the plan. Again, everything's kind of out in the future. We'll see that product come to market, well, if it's 2012 server product, then this year, and then very shortly thereafter, you should expect to see solutions come out.
I'm curious, there's a lot of questions on Windows Server 2012. Are people expecting to deploy soon after release? Is that, yeah?
As TAP customers, or just kind of in production because there's some fantastic functionality in there? Both? All right.
Good.
2012 is a great example of the evolution of a lot of this stuff. And Hyper-V v3 is going to open a lot of new opportunities where perhaps Hyper-V was kind of limited today. So it's going to certainly be interesting. And it leverages a lot of the same functionality. So, 2012 uses the SMIS stack for a lot of the storage management, so things get easier for us. We have, so we talked about those three things. Now you can also use Windows PowerShell commandlets to operate against storage, so you don't even need us anymore. So, there's a lot of choice. So as a customer, this is going to be a fantastic opportunity to pick whatever solutions and implementations you want.
Yeah.
Is this purchased directly through EMC, and do you guys do all the licensing, support costs, everything together?
The go-to-market piece. So I keep telling people I'm a technology person. And so the question is around how do you get one of these? It's a go-to-market piece. What I can tell you is that there is a channel partner program, and we have a set of channel partners that we do work with to deliver solutions. So there will be a mechanism to get that out there. So when we come out, there will be a channel partner play. If you're really interested in we always get dinged about trying to sell stuff, and I don't really want to sell it. So go to emc.com and look at vSpecs as an example of what we might be able to do. But the technology is all wrapped up, and this is about the technology, right? So you can do this stuff, and there are a lot of other vendors out there that are doing the same sorts of things. But it really is trying to optimize your experience and give you the best of all worlds. We only touched on those things that do the storage infrastructure. There is so much more in System Center. So,
and I would say too, if it is something you want to follow up with, feel free to see me afterwards. We can trade information, and I can help put you in touch, because we are working to define the process a little bit more about that. Yeah.
All right.
Anything else?
Nothing else? All right. Thanks very much.
Thank you.
Thanks for hanging out.